Hello, this is Mr. Collier, and today we're looking at the derivative at a point and intervals of increase or decrease using derivatives. Okay, so first we're going to do it manually, and then we're going to use our GDC to figure out where the slope, or what the slope is at a certain point. So this one here, we have the derivative, let's say dy dx equals 4 times 3 is 12x to the power negative 3. And we'll substitute x equals 2 into the derivative, and we get, let's write slope equals the derivative, so this is the slope, and that is 96. So when we do this on the calculator, we should get the same value. So let's check it out on the HP Prime calculator. I'm going to go to apps, I'm going to type in the equation. It is 3x to the power of 4. And then, so type in the original function and then go to plot. And here it is. Now, if you want to get the slope at the point 2, then we have to go to point 2 first. So we go to menu, go to, and you type in 2, enter, and the cursor is now at the point where x equals 2. It looks very steep here. Let's see if it's 96. Function, slope. It is indeed 96 right here. Okay, so your calculator can do that work for you. Let's do another one down here. Let's do this last one here. So if we find the derivative, r prime of x, first let's rewrite the function as 3x to the power of negative 2. Then the derivative is negative 2 times 3 is negative 6. Reduce the exponent by 1. So if I substitute in x equals 2, we get the slope at the point x equals 2 is negative 6. Let me rewrite this. Negative 6 over 2 cubed, which is negative 3/4. Okay, so let's see if we get that on the calculator. So let's type in the function, which is 3 over x squared, and plot. Let me try that again. I think sometimes I have to use this x. I actually have to press enter and then plot, and there we go. That's what the graph looks like. And at the point x equal 2, we go to menu, go to, click in 2 here. Okay, the cursor is now at 2. And we click on functions. Oh, I clicked on the wrong thing. Function, slope. I think I went to the wrong spot. I have to go back again because I made a mistake. Go to function. Go to 2, enter. Now I'm back at 2, function, slope. So it is negative 0.75, which is the same as negative 3/4. Okay, so let's look at where the function is increasing and decreasing. So if the slope of the tangent is positive or increasing at a maximum or minimum or an inflection point, we have the slope is 0. And over here we have a negative slope. Let's say it's less than 0. Okay, and that corresponds to the derivative. So on this point, the derivative equals 0. Here, the derivative is greater than 0. Here, the derivative is less than 0. So in this example here, if we want to write down the intervals of increasing and decreasing, let's write those down. Increasing, decreasing. So it's increasing only in this part. This is where the tangent lines are positive. So that's from negative 1 to 1, and the way we write that is x is between negative 1 and 1. We have two zones where it's decreasing, here and here. So we can say x is less than negative 1 and x is greater than 1 are the two intervals of decreasing. Let's skip down to here. All right, so let's take a look at this. This is another way of saying it's decreasing, right? The derivative is less than 0, so this is decreasing. And here is called a stationary point. Okay, stationary point is where the derivative equals 0. Here we have increasing. Okay, so think about that. Let's think about a parabola, even though it's not necessarily a parabola. If we have decreasing and then stationary and then increasing, what we have is actually a minimum point, a minimum value for y. So when we have this situation where we go from decreasing to stationary to increasing at the point C, then at x equals c there is a minimum. Okay, and here we have increasing, stationary, decreasing. So that looks like, that second situation looks like this. And that is, of course, a maximum. All right, so we can use the derivative to help us determine minimums and maximums. Okay, let's take a look at this function. Let's find the derivative. So the derivative is 2 times 2 is 4x, and that is plus 3. So that's the derivative. Use the derivative to determine the x-coordinate of the stationary point. So at the stationary point, the derivative equals 0. Okay, so we take this function, replace the f prime of x with 0. 0 equals 4x plus 3. 4x equals negative 3. X equals negative 3 over 4. Okay, so that is the stationary point. We know it is a parabola that is pointing up. Okay, a parabola that's pointing up because the a value is positive, and the x value there is negative 3/4. So when is it increasing? It's increasing when x is greater than negative 3/4. Okay, let's skip down to this real life question right here. Ball is thrown and it's modeled by, the height is modeled by, or the path is modeled by this function. So let's find the derivative. So we can do 2 times this is negative 0.1x, and this becomes just 1.5. Hence, find the maximum height. The hence is a very important word. That's an IB command term for you have to use the derivative. So to get the maximum height, at maximums and minimums, the derivative equals 0. So we set it equal to 0. That's a 1.5. And solve for x. So this is 0.1x equals 1.5. X equals 1.5 divided by 0.1. That is 15. Okay, that is 15. That 15 is the x value at the maximum height. We have to find the y value, so we substitute 15 into the equation. Okay, so we're going to figure that out, what that is on our calculator. I'm going to actually not type all that in, just type it in as a function. So we've got negative 0.05 x squared plus 1.5x plus 82. Okay, so let's plot it. Okay, there's the parabola. I can see the maximum. Yeah, so let's actually just calculate the maximum, and that'll be the answer. That's 93.25. 93.25 meters. Okay. Now part C, justify that the height is a maximum. Well, we can see from the graph that it's a downward facing parabola. Actually, we know it's a maximum, right, because we know it's an upside down parabola, right? We can also say, now this is 15. We can also say f prime of x is greater than, or sorry, yes, so that's right, greater than 0 for x less than 15. F prime of x is greater than 0 for x greater than 15. And f prime of x equals 0 for x equals 15. Therefore, it must be a maximum. Therefore, f of x has a maximum point at x equals 15. Okay, one more example. Find the derivative in terms of a. A is just a constant like 2 or 3. We just don't know what it is. So we can find the derivative like normally. Derivative of x squared is 2x. And a constant times x is just that constant. So there's the derivative. It says f of x has a stationary point when x equals 3. So you can just, or that means f prime of x equals 0. So let's do this now. So 0 equals, this is the derivative. X is 3 at this particular point. So we get a equals 6.